Hello everyone, this is Mitsuhiro Hayashibe from Tohoku University, Japan. This presentation is for EMBC 2020. Title is Personalized Balance and Fall Risk Visualization with Kinect 2. This is the background of this work. There's a situation by 2050, 16% of the world's population will become over 65 years old. Patients in need of neuro-rehabilitation assistance are increasing in our aging society all over the world. So we would like to develop karaoke-like system in rehabilitation to quantify the motor ability with automated way with easy setup. So already some research groups have worked on such system for balance rehabilitation, which use video game. However, often the system is letting patients to play the video game. However, it's very rare to have personalized modeling information of the patient's body regarding balance. So we think it's important to have personalized COM estimation at home because if we know the exact COM position, it can quantify well the subject balance status. But doing so to identify the COM parameter at home environment is challenging. And there's the importance of personalized models because the subject mass distribution changes by sex and custom to making exercise and different issues makes a different situation for having different mass distribution. In biomechanics, this kind of anthropometric tables are used to estimate center of mass. However, this table is typically taken from standard normal subject data. So potentially for the patient in rehabilitation, specialized body parameters can happen. So it's very can be difficult to apply this table. And in biomechanics, this kind of method for identifying segment parameters is reported. However, of course, it's annoying to make such experiment. And advanced method is proposed, like segment dynamics parameter is identified by using advanced motion capture and force platform, but it's required to have high-end motion capture and a very accurate force sensing, which is limiting the use at home. So our objective is to have home-based application with using portable sensors and allowing self-identification by users. And finally, to have real-time balance assessment. So this is the scene where how personalized COM is identified. So we ask subjects to take potential postures they may take, and we take postures changes, and also we use Weeboard for the changes of COP. And from there, we identify the center of mass. So this paper is not focused on this identification process, so please refer to this reference. So this paper focuses more on the balance stability evaluation. So after getting personalized COM, we use the angular momentum regarding center of mass, and also importantly to estimate the support polygon. Which is also very important because foot location changes by the motions. And finally, we can get personalized stability index. And one appeal of this method is we no need of force platform, but we can have balance estimate. So for Z-RAM point computation, this is the zero rate of change of angular momentum, and this is a point in the ground level to have zero rate of change of centroidal angular momentum. And this method is proposed by Goswami 2004. And also important to have different foot situations like 2 foot or 1 foot, or it depends on where 2 foot we may have. And also sometimes the foot may, like toe standing, can also happen. So we have used minimum volume enclosing ellipsoid method to adaptively change the support polygon. So by using Kinect 2, we detect foot location and we create this enclosing ellipsoid. And against this ellipsoid, we evaluate the Z-run point position related to this ellipsoid, and we finally can decide the stability. If it's center of the ellipsoid, it gets more stable, and if it's far from this ellipsoid, it's getting unstable. And this is the scene where this method is applied. And this is the scene where subject is doing functional reaching, and you can see that the drum point is well moving towards that reaching direction of the hand, and instability increase. And this is a scene where the dance applied for the dance motions. And as you can see that it's quantify also for dynamical motions, and the Z-run point is reflecting well how a balance point changes against foot location. And this is a scene where we use Kinect 2 as the sensing sensors, and compared to Kinect 1, it gets much stable skeleton tracking, and also foot tracking also very accurate. So finally, like this video, and for different postures, it can quantify well the change of the balance status. And you may note that if he stands on right side or left leg, and well, the drum point is changing position towards that supporting balance point. Also, we have verified this system with 10 able-bodied subjects, and in this test we have checked with different posture tasks like 2 foot standing or 1 leg standing, and eye closed and eye open. So against 2 legs standing, by having 1 leg stand, instability increase. And in addition, if subject close eye, and instability increase. And this system can quantify well the change of the balance, and according to therapist's opinion, it's well reflecting their sensation of regarding the balance changes. The conclusion, personalized COM estimation can be obtained only by using Kinect information. The obtained COM is also valid for dynamic motions, as it takes into account the acceleration of COM. Stable adaptive support polygon extraction was difficult with Kinect 1 by its limitation of accuracy and frame rate, but it could be well managed with Kinect 2 sensor. Fall risks can be visualized in real time while taking into account the subject body parameters. We are now developing game-based rehabilitation system with this balance evaluation feature. Thank you very much for your kind attention. And if you have interest, please visit our website.